This is Geometry Unit 9, Day 8, working on perimeter and area. The entire distance around a polygon is called the perimeter. The region enclosed by an object is called the area. So the perimeter would be the fence around your backyard, and the area would be the grass within it. This lesson is not based on teaching you new material, but rather being sure that you have the understanding of what the formulas would mean and how to use it here in the coordinate format. When we talk about area, what we're doing is taking the number of squares that land inside of a shape and counting those up as a square area calculation. So each side of the square, all these squares should theoretically be the same size. If they were both 1 feet apiece, then we would count the number of squares and call it that number feet squared, or by square feet. When we talk about area, we take the length of one side and we take the length of another side. So often we call it base and height, or length and width. Different ways to have phrased it. 1, 2, 3, 4, 5, 6, 7, 8. So the base is 8. There are 8 squares across. There are 3 squares up. So that would be a quick calculation for adding 8 plus 8 plus 8. You add 8 3 different times. So that's 8 times 3. That's the total area, the number of squares that are inside this rectangle. That's what area is. So area is calculated by base times height. A triangle is very much the same thing. We would first think about it as forming a rectangle around, breaking that rectangle up into equal pieces, all the same size. Theoretically, my picture may not be perfect here. So you would want to look in here and see how many squares fit inside this triangle. Now what's tricky about a triangle is that there's going to be several pieces that the whole square doesn't fit in. So you can't call it a whole square. You would theoretically have to take the pieces and connect them so that you finally get a full square. And then you would have to count the number of full squares. And that's where the decimals will come in a lot with triangles, because it may not come out to be a perfect whole number. But when you look here, the calculation, if you had a triangle inside of a rectangle, it would still be the whole base times the whole height, and it would be half that value. So we learned that the formula for a triangle is half base times height. That works even here when you don't have a right angle part of the triangle. But to calculate the height with the base, they need to always be perpendicular. So for a rectangle, that's always 90 degrees at the corner. That's a requirement of a rectangle. But that's not a requirement in every triangle. Notice that here we find the height that's perpendicular to this base. The base is not always horizontal. Sometimes it can be turned, and you would just have to recognize what is a value that I know that is perpendicular to another one. Sometimes it'll be the actual sides of the triangle. If there's a right angle, if it's a right triangle, then you can actually use the sides of the right triangle, the legs. But often you have to find the height differently. So here we're going to take our shape, we'll plot the points, -3, -2, -3, 3, 1, 6, And then we'll connect the points. Well, this should have been 1, 6. We'll connect the points in consecutive order. And we have 5 different sides, 5 different vertices. So that's actually called a pentagon. And we're going to look for the perimeter and the area of this pentagon. Well, perimeter is like the fence around a property line. You need to know the length of each side of this pentagon. So we'll start calculating the perimeter by looking at the length of AB. Because AB is vertical, we're able to count that length. If it's horizontal, we can count that length. But if it's slanted, you can't count how long that value is by the squares. You can only do that horizontally and vertically. So we'd have to use a distance formula. AB is a length of 5. But BC is slanted. If you recognize the Pythagorean triple, that would be outstanding. If not, you can use the distance formula from B to C, x2 minus x1 plus y2 minus y1 group your like terms together. 16 plus 9 is the square root of 25, which comes out to be 5. So that was a Pythagorean triple of 3, 4, and 5. CD. The square root of x1 minus x2 and y1 minus y2. I'm getting these values by looking up at point C and point D, my x values and my y values. It doesn't matter which point is considered point 1 and point 2. You just need to be consistent throughout the problem. So this comes out to be negative 6 squared and 3 squared. That's 36 plus 9, which is the square root of 45. For this problem, that would be enough. But just want to practice a little bit on reminding us about how to simplify a radical. You look for the factors that make 45. Some people say 15 and 3. Other people might say 9 and 5. We'll get the same answer either way we look at it. But do recognize that if you use 9 and 5, 9 is a perfect square. 9 is made up of 3 times 3. So take the square root of 9 is really easy. So we get 3. We don't know the square root of 5, so that stays inside the square root. And that can be simplified as 3 root 5. DE is a length of 5. And then AE is a length of 10. So to calculate the perimeter, we're going to take all those lengths, 5 plus 5 plus the square root of 45. You could use 3 root 5 if you want. Plus the 5 plus the 10. So this comes out to be 25 plus the square root of 45. Using a calculator, that'll come out to 31.7, and we'll use units. It's not squared because it's a length. That's our perimeter. Next, we're going to look at area. Area, we've learned 2 formulas, or we're working with 2 formulas. One for a rectangle and one for a triangle. For most polygons, you should be able to break it into either rectangles or triangles. So this particular, you could do it a couple different ways. You have some choices. Here would be a typical way to break this rectangle up, or this pentagon up. Break it into a rectangle. So we have this shaded region, and we can find its area relatively easy. We're 10 along that side. We're 5 along that side. So to calculate the area, we would see that as 10 times 5. So there's 50 squares. Actually, you go through there and count them. There are 50 squares in there, so that's your area. When we come up here to the triangle, it's a little trickier. We have to look at what the height is, and we have to look at what the base is. If I look at these sides, maybe I could take BC times CD and take half of that, half of base times height. These aren't actually the base and height because they're not perpendicular to each other. Their slopes are not opposite reciprocals. This slope is 3 over 4, and this slope is down 3 over 6, which is 1/2. They're not opposite reciprocals. So we need to look for another set that happen to be perpendicular. Here's a horizontal line, which is a length of 10. Here's a vertical line, which is a length of 3. So that's easy way to recognize that that's perpendicular. So we're going to take half of the base times the height to calculate the area of the triangle. So to find the area of this polygon, we're going to take area of the rectangle plus the area of triangle. Gotta get the right letters in there. So the area of the rectangle was base times height. So that's 5 times 10. The area of the triangle is half of base times height. The base is 10, and the height, being a measurement perpendicular, is 3. So that's 50 plus 30 divided by 2, which is 15. So that comes out to be 65 units squared. So we have square units. If you counted through here, we talked about 50. If you counted the remaining that are inside the triangle, you should get 15 more. So that would come out to 65. If you actually count it, you might approximate some of these a little bit differently and come up close. But it does come out to be exactly 65 units squared.